We're going to take a look now at numeric patterns and flow diagrams in grade 5. You've done a bit of this in grade 4 before, so this should be a good revision. Let's go and take a look. So first of all, let's get some terminology out the way. What do we mean by a flow diagram? Well, a flow diagram is simply a diagram that shows how an operation is applied to a number to get an answer. It's just a visual diagram to say, what are we doing? Are we adding? Are we dividing? Are we multiplying? What is an input number? That's the number that you start with in your flow diagram. What do we mean by output number? Well, that's the answer that you get in a flow diagram. What do we mean by a number sequence? This is a group of numbers that follow each other in a particular order. It has a certain pattern. What is a number sequence? A number sequence is a group of numbers that follow each other in a particular order. In some number sequences, the same number is either added or subtracted to get the next number. For example, 2, 4, 6, 8. What are we doing here? We are adding 2 to every number to get the next one, because 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. Whereas what would we be doing here? If I went 3, and then the next one was 6, and the next one was 12. Well, now I'm multiplying. 3 times 2 is 6. 6 times 2 gives you 12. Here I'm multiplying by the same number. Here I'm adding. Both of these are number patterns or number sequences. Okay, let's go and take a look at some examples. So if we look at this first example, how would you complete this? Well, if we go 3, 5, 7, 9, what are we doing? To go from 3 to 5, we add 2. To go from 5 to 7, we add 2. To go from 7 to 9, we add 2. So we keep adding 2. So after 9, we're going to get 11. After 11, we're going to get 13 and then 15. It's really important that you are able to identify a pattern. You look at the numbers and you figure out what is happening. Are we adding a number? Are we dividing by a number? Are we multiplying by a number? What are we doing to that number to get the next one? Once you've figured that out, that's a rule. There's a rule that you figured out. Either the rule is add 2 to every number, or multiply every number by 2, or divide every number by 2, or subtract 2 from every number. You need to figure that out and then continue the pattern. Let's see if we can figure out the next one. So if we look at the next one, it says 2, 4, 8, 16. Now, you can see we're not adding numbers, because to go from 2 to 4, we add 2. 4 to 8, we're adding 4. So that's not correct. That's not the pattern. But what happens if we multiply 2 by 2? We get 4. And if we multiply 4 by 2, we get 8. And if we multiply 8 by 2, we get 16. So the rule or pattern for this one is we keep multiplying by 2. So if we multiply 16 by 2, this one will become 32. If we multiply the 32 by 2, we get 64. If we multiply the 64 by 2, well, what is 60 and 60? 60 and 60 gives you 120. And then you've got a 4 and a 4. So 4 and 4 is 8. 120 plus 8 gives you 128. So if we multiply the 64 by 2, we then get to 128. Let's go and see how we can show this in a diagram, in a flow diagram, and how we also learn that the concept of a multiplication and a division is an inverse operation. So here in my diagram, I've got an 8, and then it says multiply that 8 by 9 to arrive at the answer of 72. But if you now take the 72 and you do the inverse operation, you now divide the 72 by 9, you get back to 8. So what we're saying is 8 times 9 gives us the 72. But if we take the 72 and we divide it by 9, we're going to get back to 8. Or if we took the 72 divided by 8, we'd get 9. So either way, or we could say 9 times 8 here is 72. The order does not matter. So division and multiplication are opposite operations. What about understanding what we mean by multiples of 100 or 1,000? Well, let's take that up as a new concept. So the next concept we'll look at separately is multiples of 100 and 1,000. In the meantime, remember what inverse operations are and how you can show them on a flow diagram.